In this lecture, we are going to see how to construct angular momentum wave function. So the total wave function psi sub NLM, which is a function of r theta phi in spherical coordinate system, can be separated into two parts. That is r NL of r, which is a function of r. This is the radial part of wave function, which we have seen already. Then in this section, we are going to find how to construct YLM, uh, which is a function of theta and pi. This is the angular part of wave function. This we are going to find it now, how to construct this. For that, first we need is Legendre polynomial. By definition, the Legendre polynomial is PL of x is equal to 1 over 2 power L, L factorial, t over tx whole power L, x squared minus 1 whole power L, and the associated Legendre function. After this, we need the associated Legendre function in which we have to substitute this one. That is, by definition, PLM of x is equal to minus 1 modulus m, 1 minus x squared modulus m over 2, t over tx power modulus m, PL of x. Here we have to substitute what we have calculated here. And one more thing is, you see, uh, this does not depend whether m is negative or positive, because it's a modulus m we are going to consider this. And finally, after calculating PLM, we are going to calculate YLM, which is a function of theta and pi, which is equal to square root of 2L plus 1 over 4 pi, L minus m factorial over L plus m factorial, e power I m pi, and PLM of cos theta. This only we have to calculate from this one. So this is the way to calculate. First you calculate the Legendre polynomial, then associated Legendre function, finally the angular part of the wave function. First, we will find the angular part of the wave function, YLM, where L equal to 0, M also equal to 0. Then PL of X, where L is equal to 0, is equal to 1 over 2 power L over L factorial, 1 over 2 power L, L factorial, d over dx power L, x squared minus 1 power whole power L. Here L is equal to 0. So everything will become 1, because 2 power 0 is 1, 0 factorial also 1. Here you need not differentiate, because t by dx power 0. Then this is also 0. This will be 1. So everything will be 1. Then P is P naught cos theta is equal to 1. Here I am replacing x by cos theta. I am not replacing here cos theta, because we are going to differentiate with x. So first carry out the differentiation, then you replace x as x by cos theta. So P cos theta is equal to 1. Then what is PLM? That is P00 cos theta is equal to minus 1, by definition, minus 1 whole power modulus m. Remember that this is modulus m. So you need not worry whether m is plus or minus. So 1 minus x squared modulus m over 2. Uh, First order derivative with respect to x power modulus m p naught cos theta. Here m also 0. This will be 1. This also 1. Then this differential part will go away, because this will become 1. M is 0. Then only remaining thing is P0, PL cos theta, that is P0 cos theta, which is equal to 1. So P00 cos theta is equal to 1. Now you can find the angular part of the wave function. YLM, which is a function of theta and pi, by definition is equal to square root of 2L plus 1 over 4 pi L minus M factorial over L plus M factorial. Here L and M is 1, L and M is 0. So 0 factorial, 0 factorial. 0 factorial is 1. Here also it is 0 factorial is 1. This entire thing will become 1. So here is a exponential Im pi. M is 0, so this also will become 1. Then in the square root, you have L. L is 1. So 2 plus 1, 3. So 0. L is 0. So you will put 2L is 0 here plus 1 over 4 pi. This is 0 factorial over 0 factorial, 1 by 1. So that the exponential term also 1. What is PLM cos theta? In this case, P00 cos theta equal to 1. This also 1. So naturally, you will get only the term left is square root of 1 over 4 pi. Other things are 1. Multiplicative factor is 1. So you can write y00, which is a function of theta and pi, is equal to square root of 1 over 4 pi. This is the angular part of the wave function for L equal to 1, L equal to 0 and M equal to 0. Now you take the case L is equal to 1 and M equal to 0. So now PL x, that is P1 x is equal to 1 over 2 power L factorial t by dx of L power L x square minus 1 power L. Here 2 power L, here L is 1. So this is 2, 1 factorial is 1. So this term will become just half 1 over 2. Then you are going to differentiate t over dx x squared minus 1. This is power 1. So if you differentiate minus 1, it will be 0. Only a differentiable parameter is x squared. So if you differentiate this, you will get 2x. Remember that I am not replacing this cos theta because that differentiation will become complicated. So now you can cancel this 2 and this 2. So P1 x is equal to just the x. Now what is PLM? That is L equal to 1, M equal to 0. Here even M equal to 0, these two terms will become 1. 1 multiplied by 1, 1. And this is a derivative of P1x. So P1x is just the x. If you, here M equal to 0, this also will become 1. This is become 1. So only thing is P1 of x. What is P1 of x? P1 of x is just the x. Now you replace x. So yeah, now you replace x as cos theta. Then P10 cos theta is equal to cos theta because we are replacing x by cos theta. As I said, we are not replacing at the beginning itself because this differential operator is with respect to x. Now you can find y10 of theta, which is a function of theta pi. So here L is 1 and M equal to 0. So here you will get L is 1. This will be L is 1 and M is 0. Here L is 1, M is 0. So L factorial over L factorial. This will become 1. Then here L is 1. 2 plus 1, 3. So square root of 3 over 4 pi. And what about M is 0? So naturally this also will become 1. And PLM cos theta, that is P10 cos theta equal to cos theta. So the radial part of wave function for L equal to 1 and M equal to 0 is equal to square root of 3 over 4 pi cos theta. Now we will move on the other part. Now we are going to find the angular part of wave function for L equal to 1 and M equal to 1. Here you can see already we have seen P1 of x, that is PLx is equal to x, and P11 can be written as L equal to 1, M equal to 1. So you can write this by definition, it is minus 1 power modulus M 1 minus x squared power modulus M over 2 T over Tx power modulus M P1 of x. Here you remember that whether it is P1 plus 1 or P1 minus 1 immaterial, because you are taking minor modulus for M. So that you keep it in your mind. P1 1 is of x is equal to this is 1, so minus 1 this will be. And what about this? This will be 1 over 2, 1 minus x square 1 over 2, and here m is equal to 1, so t over tx, and we know p1 of x is x. If you differentiate this, you will get 1. That's what I have written. You have minus 1 already, minus 1, 1 minus x square whole power 1 over 2. Now P1 of 1 is equal to minus 1. Now I am going to replace x by cos theta. As I said, I am not replacing here because this differential will become complicated. So cos theta is equal to minus 1, 1 minus cos square theta power of 1 minus cos square theta is sin square theta. If you take square root, that is 1 over 2, then that will become simply sine theta. Here you have minus 1. So this will be minus sine theta. That is P1 of 1 cos theta is equal to minus sine theta. Now we have found P11 of cos theta equal to minus sine theta. Then YLM of theta and pi is equal to, by definition, the square root of 2L usual 2L plus 1 over 4 pi L minus M factorial over L plus M factorial, and EIM pi PLM cos theta. So here L equal to 1 and M equal to 1. So what will happen? This will become 2 plus 1, 3, 3 over 4 pi. And here 1 minus 1 is 0, 0 factorial divided by 1 plus 1, 2 factorial. Here M is equal to 1. This will become e power I pi because m is equal to 1. Then PLM, that is P11 is equal to minus sine theta. So you can write 0 factorial is 1, 2 factorial is 2. So you multiply 4 pi with this 2. You will get, and take the negative sign at the front. So minus square root of 3 over 8 pi, this e power I pi sine theta. This is the angular part of the wave function for L equal to 1 and M equal to 1. We have seen that y11 is equal to minus square root of 3 over 8 pi e power I pi sine theta. Now we have to find the value for y1 minus 1. That is here L equal to 1 and M equal to minus 1. So use the standard relation for negative m, that is y 1 minus 1 is equal to minus 1 power modulus m y11 theta pi complex conjugate. So it will become m is minus 1. So this is modulus 1 is 1. Minus 1, already there is minus here, which will become plus. Then 3 over 8 pi, you are taking complex conjugate. That is e power I pi will become e power minus I power I pi sine theta. So the sine theta I am taking as it is. So for y equal to 1, 1, we have seen there is a negative sign. Here negative sign gone away. So we can generalize that y1 plus or minus 1 equal to minus or plus, because for plus 1 it is minus, for minus 1 it is plus. So this will become minus or plus square root of 3 over 8 pi. Same thing with here you can see for plus 1 it is e power I pi, and minus 1 e power minus I pi, same sign, e power plus or minus I pi sine theta. So you can see for m equal to L equal to 1, m take a value of 1 0 minus 1. So we have seen m value is 0 already we have seen, and we have seen now m value is 1. So 0 already we have seen, 1 already we have seen, then minus 1 just now we have seen. If you find this lecture useful one, kindly subscribe my channel, and share it, and join my channel for the growth of my channel. Thank you very much for watching my video and supporting me continuously. Thank you very much.